Hello and welcome everyone. My name is Belgin. I am Specialist Solutions Architect in in-memory databases team at AWS. Today we also have Riaz. He's a Specialist SA in in-memory databases team as well. So today we're excited to talk to you about how you can turbocharge your RDS applications performance with ElastiCache for Redis. Let's quickly go on the agenda today. I'm going to talk about the performance challenges that you are facing relational databases, and then I will briefly introduce the ElastiCache for Redis, and then I will walk through with you the caching overview, and then at the end, Riaz will be showing you a demo session. So in an article from Business News Daily, it was stated that if your site is slow, even by just a few seconds, you lost customers. A slow site can result in 90% of users leaving your site. 57% of users will take their business in somewhere else, and 25% of them will never return. One important fact to understand is that memory is at least 50 times faster than SSDs, and it's also predictable because the response time is consistent versus disk seek time, especially if it is mechanical disks. But even for SSDs, when they get overloaded, you can get a significant increase in response time. So you are going to have a situation where Akamai's study was able to see that a 100 millisecond delay in web load time can hurt conversion rates by 7%, and a 2-second delay in web page load time increases bounce rate by 103%. So these numbers tell us speed is critically important to our customers. This really shows that you can get the faster response time to your users, the more engaged they are going to be. And that's sure important, especially when engagement depends on revenue. So that's why performance matters for our services. Here is a quick comparison of characteristics of disk and memory-based systems. It is clearly the biggest difference is data is stored in memory versus on disk. And it means the engine does not have to wait for slow disk for read or write operations. The writes and reads significantly slower in disk-based systems when you compare with in memory. The latency in disk-based databases in milliseconds, whereas the latency in memory databases is microseconds. The disk itself is mostly the bottleneck in disk-based databases. In memory-based databases, the bottlenecks is usually network because memory is faster than network and disk. And the disk-based databases throughput mostly moderate, whereas the in-memory databases can provide high throughputs. And disk-based relational databases usually have strict schemas and data models. In-memory databases has the rich data structures. So regarding the performance and scalar aspects with relational databases, it cannot be easily scaled out and scaled back down. So, and complex and slow running queries slow down the applications. So as we discuss how this slowness or latency can affect the users, and you may lose users due to these latencies. Let's quickly check Redis, ElastiCache for Redis service. So here is a quick snapshot of our purpose-built databases in AWS. And we have different databases for helping our customers different use cases like RDS for relational purposes, DynamoDB for key value stores, etc. So one database does not suit every use case. You can select one of that databases that suits for your use case. Today, we are going to talk about ElastiCache within memory databases class. We also have MemoryDB in that class. So just quickly on MemoryDB, it is a new service that has been launched last year. Due to its high durability and consistency features, it can be used to store any mission critical data, and that means it can be used as a primary database for many use cases. Whereas the primary use case for ElastiCache is caching, and any use case that needs to store ephemeral data with a high throughput and high performance can use ElastiCache. And Amazon ElastiCache mostly works side by side with one or more of the disk-based AWS relational or NoSQL databases or any other data stores. So you can think of ElastiCache as the first responder for your application data feeds, taking a lot of pressure off the primary data stores while turbocharging your application performance. So let's check the ElastiCache more closely. Amazon ElastiCache offers two different engines actually, Redis and Memcached. Redis and Memcached is open source engines actually. So ElastiCache fully compatible with open source Redis and Memcached. So that means if you're currently using using Redis or Memcached in your on-prem system or maybe self-managed systems, then you don't need to change any APIs to move to ElastiCache, because you can use same APIs to communicate with ElastiCache, and it is secure and reliable. We launch ElastiCache nodes in your VPC, which brings you default security features within VPC. So you can use security groups or subnet groups within ElastiCache. And also there is encryption at rest and in transit option. So when you enable encryption in transit, it means your client and ElastiCache communication will be encrypted, and it is the within the cluster, primary and replica communication will be also encrypted. And also it provides you multi-AZ option with automatic failover feature, which brings you high availability, and if something happens to your primary node, it will fail over to one of the replica nodes, and you can continue to work with your cluster. And it is easy to scale. You can scale up to 500 nodes, and also you can add more shards to have more write operations power, and you can add read replicas for getting more read operations. And of course it provides extreme performance. The data is in memory, and the response times are microsecond level. So what are the use cases for ElastiCache? Well, the first one is the obvious one, which is caching, but real-time analytics is becoming more important. Gaming leaderboards are common, and geospatial data is great for applications that need to quickly find something nearby location. For example, ride-hailing companies, they depend on geospatial data to be able to help their drivers and customers with location services. And then you've got things like media streaming, session stores, chat applications, message queries, and machine learning too. So we are going to talk about ElastiCache for Redis here. There are two main features that makes Redis great fit for these use cases. First, Redis stores data in memory, not on disk. That makes it very fast. Second, we do not reach out data in bits and pieces. We are acting on real data structures across the network. And in Redis, we have different data structures. Each has its own behaviors, strengths, and commands, just like the data structure you use in software development. Think the first client write a data as key A and value 1 into the Redis. All of the other clients have sub-milliseconds access to that value when they want to read or update it. This is a very simple explanation, but it is actually a core concept behind the query caching and several use cases. For caching purposes, you might get the query result and stored in a string or hash or set or sorted set data structure, and all of the other clients get benefit from what first client already done. So let's talk about kind of data stored in a typical relational database and compare with the data structures in Redis. Let's take a look into how data flows between client and a server within relational databases. Imagine you have two data sets and you're frequently moving elements from one data set to another. How is the flow in a classic relational database approach? First, we will need to fetch the data from database. So we will generate a SQL and send it to database. And the database then will process the statement and it will find the data on the disk, possibly across several tables, and then prepare to be sent back to client. Then the client may have to do some type of object relational mapping process and prepare the object. So we have two data sets. So we have to do the same steps for the second data set. We generate the SQL and send it across the database, and database process in and send the reply to client. At only that point, we have the objects that we need to do the actual change. So we remove the element from set A and add to set B. Then we need to send the data set A back and the same for data set B. Then we receive the final OK from the database. So in that flow, we have 16 steps, and in several steps, database needed to read from disk or write to disk, and also a lot of communication between the client and server happened. So let's see how that can be done in Redis. There is a Redis command rpop lpush, which stands for right pop, left push, that works with list data structure. It takes an element from the end of one list and add it in the beginning of the other list. All we need to do is passing the key names as an argument to rpop lpush command. So Redis received this request and it knows where the data is in memory. All that it needs to do is update the memory pointers for the list elements, which takes microseconds to complete. Once it's done, server sends OK to the clients, and that's it. So if this access happens in frequent basis, you may not notice the differences between disk-based relational database or Redis. But if you have tens of thousands of clients doing that every second, then you're gonna definitely notice the difference. So this data structure is in memory, and I'm going to go over these data structure in next slide. Each data type in Redis has its own commands associated with it, as shown in the right column. So these commands are specific and take various arguments depending on the command. Some commands are also variety, with meaning that they can take an unlimited number of arguments, sometimes in a certain order. So let's take a look at some of the native Redis features we support inside Amazon in-memory database services and how you can use them to tackle certain use cases. The most basic type is string, which is really just a sequence of bytes. Strings in Redis are binary safe, so you can store almost anything in them, including things like HTML codes, JPEGs, and it is very popular for caching. The second, we have list. In Redis, the list type is implemented using linked lists, actually. So linked lists are optimized for adding elements very quickly to the beginning or end of them. They have push and pop functionality, allowing you to use them effectively as stacks. So in previous slide, we used list data type to show the process actually. So Redis also has two data structures for storing unique collections of strings, sets, and sorted sets. The key difference between the two is, of course, that the sorted set is sorted. So you can add elements to a sorted set in any order. And Redis itself ensures that they will be sorted on the backend. This makes sorted sets ideal for use case in leaderboard use cases. And you can also sort like top voted answers in your blog, for example. A hash in Redis is a generic map of keys and values and making them the ideal data structure for storing complex objects. For example, the key could be the user ID, and attributes could be like their name, address, and so on. And hashes are memory efficient and allow for fast queries of named elements without retrieving the whole hash object. And Redis also contains more advanced data types in streams, geospatial lookups, which our customers uses quite a bit across their microservices, and hyperlog logs, which is an approximation technique for tackling the count listing problem. And also we recently included JSON data type. So you may simply use JSON objects and recursive JSON objects within JSON data type within Redis. So moving forward to talk about caching, that is the most common use case for ElastiCache. So here we have EC2, Amazon EC2 instances as a compute layer, and we have RDS as a database. So think about when you write something to Amazon RDS, and when you want to read that data from your application, then all write and reads goes through the Amazon RDS. So it's all disk-based. And let's think you put Amazon ElastiCache as a caching layer. And in that case, when you write something to RDS, you can offload the read operations to caching layer. So since the cache will be in memory, it will improve the query response time for your users. And it will release pressure from your data store from Amazon RDS, actually in our case. And then it may allow you to put new workloads on your existing RDS services. So it will bring you fast performance and relieve pressure from your backend services. Now, can we cache more than just relational database queries? And actually, the answer is yes, we can. So the data can be coming from RDS, S3, Redshift, or an API call where you are retrieve data from an underlying or a legacy application. So that result can be cached in ElastiCache. So not just relational databases such as Amazon Neptune, which is our purpose-built high-performance graph database, can take advantage of a cache layer on top by caching your most commonly used and most resource-intensive queries. As far as you can query the data, you can cache the result in ElastiCache for ultra-fast performance. So the data source is not important. Let's see how lazy loading works. That is one of the most common approach for caching, sometimes referred as cache-side. So in here, our application runs on Amazon EC2 or Lambda or any other compute layer. It's not important. So your application, let's say your application needs to read some data. Then it will first check Amazon ElastiCache to see if the data is there. So if data is there, then it will read from cache, which means it is a cache hit actually. So your application receives data super fast. But if the data is not there, if it is not in cache, then it needs to go back to the database in our case, it is Amazon RDS. So your application needs to go back to your database and read the data from database, from the disk actually. And then it will write the result to the cache for using it in future for the other queries. So that's a simple and easy logic that you can implement as a caching strategy within your application. So let's think how that can be used in real world example. So let's think a web page that has different sections on the page, and these pages usually generated by querying multiple services from backend before being rendered. Whether they databases, microservices, or something else, it doesn't matter. So each call takes some amount of processes from the backend system, which add pressure to that system and decreases the performance for the customers because latency increases. So every time header is displayed, we probably have a query or recommendation section, or trending production is another query. We have a query for the main content, and of course we have the footer with all the information for contact of the company. For most cases, it increases pressure on the backend and the latency. So it can be dramatically improved by using Redis as a caching mechanism. So ElastiCache can be used to store cached articles, backend database queries, and basically any data that is compute intensive to retrieve or doesn't change often. So whether data changes every 10 seconds or 10 days, ElastiCache can improve response time for users by caching data for as long as it makes sense. So when tens of thousands of customers or users or more maybe are accessing a site, you can dramatically increase its performance by avoiding time-consuming requests to slower databases. So there are several data types within Redis, but most useful for the caching use case are the string, hash, and data type, and set data type actually. So write-through is another commonly used caching strategy. With write-through, we are proactively populating the cache, whereas in lazy loading, we are populating the cache in a reactive way. So in our use case, we have our application running on Amazon EC2 or let's say Lambda, not important. So when your application writes something or updates something in Amazon RDS, then it will write the data to the Amazon ElastiCache for Redis for the cache. So it means that you pre-populate the caching layer. So when you look for any data from reading the cache, it will be there because it will already write it to database and the caching layer. So this is the logic behind that write-through strategy. And here's a quick comparison of lazy loading and write-through caching strategies. So in lazy loading, we know that data is in cache because it has been queried already, and it's most likely be queried again. Within write-through, we proactively seed the cache and the data may never be used. So in lazy loading, it avoids unnecessary data in cache. We only cache the data that we may want to reach out in future. We are not copying over every bit of data into the cache. Cache can be repopulated anytime. When there is a failure or we lost data in any reason, we know the cache will be populated as read continues. So within write-through approach, cache populates when we write when write operation happens. So we already put the data, the cache to cache before, and we don't know if it's gonna read or not. And in lazy loading, when you try to fetch the data from cache, but if it is not there, you need to go back to the database and get back to the application and cache the result, which means cache miss is expensive. So within write-through approach, latency happens on write operations, which mostly would be better tolerated than the read latency actually. And in lazy loading, data can get stale. It is related with cache validation, freshness factor actually. So as the frequency of change increases in the data store, the cache data will unlikely be useful. You can partially overcome that with using time to live values, TTL actually, and then the key expires after the time you set. And within write-through, when write occurs on database, it also will occur on cache too, so the data is never stale. And in string is most commonly used data structure in lazy loading, whereas hash is mostly used in write-through. So basically, you don't have to, so we talk about two different strategies, but you don't have to select and implement only one strategy. So you can use both. The only thing stopping you implementing both of these strategies would be the time to implement actually. So implementing lazy loading approach would be quicker and you can get benefit quicker. But you can implement write-through at any time you want to. So you can combine both strategies based on your use case. You don't have to select just one and stick on that. You can combine these strategies based on your use case. So that's all from my side. I would like to pass the word to Riaz, and he will be delivering a demo for us.
Thanks, Belgin, for having me and for the great session on ElastiCache. Hello, everyone. My name is Riaz. I'm working as a specialist solutions architect in the in-memory databases here in AWS. Let's dive into the demo. As Belgin mentioned, the most popular use case of ElastiCache is database caching. We have set up this demo that showcases a lazy loading example from Amazon RDS. In this setup, we have here a client that connects to the web application, tries to query information from Amazon RDS. The application will first check if the information is present in the cache. If it is present in the cache, it is called a cache hit, and the retrieval of data will be really fast in that case. In case the item is not present in the cache, it is called a cache miss. In that case, the item needs to be fetched from Amazon RDS, which will be an expensive operation. After fetching that information from Amazon RDS, the application will update the cache so that the subsequent reads can benefit from the in-memory access of data, which will be faster. Let's see how this is handled from the code. So in the code, what we does is we construct a key for Redis from the SQL query by calculating the hash of the SQL query. So we try after once the key name is constructed, we try to fetch that key value from ElastiCache for Redis. And we have a if statement here which checks whether we succeeded in retrieving the value from the ElastiCache for Redis. If it is able to retrieve the information from ElastiCache for Redis, the statistics are updated according to the cache hit, and the information we retrieved from cache is delivered to the application which is requesting it for. If it is not able to find the value from ElastiCache, it updates the cache misses and returns the value to the application as well as update the ElastiCache for Redis with the value so that the subsequent reads can benefit from it. Let's see the demo now. The demo has a few variables which we can set, one of which is TTL or the time to live, which is in other words, in Redis terms, it is called expiry also, which the TTL actually decides how long the data should stay in ElastiCache. So in this example, it is 3000 milliseconds, which is 3 seconds. So anything that you store in cache will live only for 3 seconds in this case. And the number of different queries. So the number of different queries, as the number of different queries increases, it increases the chance of having a cache miss. So, so that is the second variable. And total number of calls is the number of calls executed in the test. So we have other variables like query complexity. The first one is query complexity low, which will be like querying a table and getting only one value from the table. We have medium query complexity. Medium query complexity will do some string related operations and group by operations like table scanning and all in the medium query complexity. We also have high query complexity where we will do the string operations as well as the table scanning and some inner joins between tables. So that is the high query complexity. The low, medium, and high query complexity only has impact on the Amazon RDS, wherein it has no, it should not have any impact on ElastiCache for Redis because ElastiCache for Redis considers all the values stored in it as a key value pair, and it doesn't have any query concept, or it should not be affected with the query complexity that we have in relational database world. So once we run this test, we can see how much cache hit ratio we were able to get, how much commands per second we were able to execute in ElastiCache versus database. And we will be also able to see what are the queries that run against the RDS. So let's begin. To begin the test, I will start with something really simple. I'll set the TTL to a second, and I'll keep the number of different queries to 50 and the total number of queries to 500. With this, we should get a 90% of cache hit ratio. Let's see how the test behaves. So the test is completed. We got 89% of cache hit ratio. As you can see, in this example, the time to fetch the information from the database was 454 microseconds, whereas the information took 133 microseconds only in when it fetched from ElastiCache for Redis. Let's see the query here. So it was, as I said, it was just getting one item from a table. So the query complexity was really low in this example. Now let's see a different test. We can increase the time to live to 3 seconds maybe, and number of different queries we will put it as 200. So the cache misses will increase in this case, and we can have total number of calls as 2000. Let's see, before that, we will also increase the query complexity to medium, and let's rerun the test. Now we have selected query complexity as medium. Let's see the query now. So it has some string operations as well as group by, which will enforce a table scan. So it is a fairly complex query for RDS. Let's see how our cache and RDS behaved in this test. So as you can see, to fetch the information from database, it was taking around 60 milliseconds, whereas The cache was able to fetch from the cache, it was taking only 133 microseconds, fairly consistent there. And overall, we were able to get a cache hit ratio of 78 because the high number of different queries we are executing. Now, let's see one more test. Um, I will have the TTL set to 10 seconds so that everything we write into the cache will live there for 10 seconds. The number of different queries I will increase slightly to 300, so the cache miss chances will increase. And we will have the total number of calls to 3000. And I'll make the query complexity to really high. Let's run the test again. Since the query complexity is high, it will take some time to complete. As you can see already, it is taking around 50 milliseconds to complete the operation in RDS level. We will let the test complete. So in this test, we were able to get around 60% of cache hit ratio. And as you can see, closely 50 milliseconds was the time taken to complete the operation in RDS, whereas ElastiCache is still consistent as expected, and it was giving only 137 microseconds per call. The query is complex. We have some string operations, some group by operations, as well as some inner joins. So the complexity of query actually influences the time taken in RDS, whereas ElastiCache is consistent as expected. So that was all from the demo. As I said, uh, as Belgin said, actually, the slowness of your website or your application can actually deviate your customers to a different provider. So, you know, if there is a RDS or relational database used in your application, it is highly recommended to use a caching layer to improve the performance as well as relieve the pressure from your persistent database layer and improve the performance of your application. Thanks everyone for listening to me. That said, I will I'll share some of the resources that you can do access using the QR code present in the screen. You can use them to further work on ElastiCache and learn more about ElastiCache. You will get access to webinars, videos, technical blogs, white papers, and other presentations. Also, I would leave some links to some other useful resources like common ElastiCache use cases, caching strategies, uh, other query caching examples, blogs, etc. Thanks everyone once again for listening to us.